Welcome to The Explainer. Today, we're going to trace the incredible story of how we, as a species, figured out the laws of the universe. And it really is an amazing story, a tale of genius, of revolution, and really a single thread of curiosity that's been passed down through generations.
You know, a great way to think about the history of physics is to picture it as this grand, multi-generational relay race. Each runner takes the baton of knowledge from the person before them. They sprint as far as they can into the unknown, and then they pass on everything they've learned to the next person in line.
So, where does this race begin? Well, we have to go all the way back to ancient Greece. This is where philosophers took the first, really brave steps away from just explaining everything with mythology and started looking for natural, rational explanations for the world around them.
So you have these early thinkers like Thales asking, hey, what is all this stuff really made of? But then you get people like Anaximander, who came up with this idea of the apron, a kind of boundless, undefined source for everything. And that was a huge step, right? Moving away from specific gods and towards these big abstract principles. But the real giant of this era was Aristotle. He created this incredibly comprehensive system to explain, well, everything. And that framework would dominate Western thought for centuries.
And for nearly 2,000 years, Aristotle's ideas were pretty much treated as fact. I mean, his theory that heavier objects fall faster than lighter ones, it just sounds right, doesn't it? His logic was powerful. But to move forward, the baton of knowledge needed a new carrier, someone who would actually test these ideas. So next, the race gets this massive jolt of energy during what we call the Islamic Golden Age. Scholars here didn't just preserve the ancient Greek knowledge, they refined it, they challenged it, and they pushed it forward in some really dramatic ways.
One of the absolute stars of this era was the brilliant Ibn al-Haytham, who you might know in the West as Al-Hazen. Now, he totally revolutionized how we understand light, but maybe even more importantly, he pioneered a whole new way of discovering the truth about anything.
And this right here is his masterstroke. He formalized the scientific method. He basically insisted that ideas, no matter how logical or clever they seem, had to be proven by experiment. This was the crucial new tool, the new baton really, that he was passing on to every scientist who would come after him.
And here's a perfect example of him putting his money where his mouth is. Through these meticulous experiments with a camera obscura, he proved that we see because light enters our eyes. Now, that might sound obvious to us, but it completely overturned a 1,000-year-old Greek theory that said our eyes shot out invisible rays. This was an absolutely monumental leap forward.
Okay, so now the runners in our race have this powerful new tool in their hands, the experimental method. And the thinkers in the European Renaissance, they were ready to grab that baton and just sprint, challenging even the most deeply held beliefs.
And one of the first people they went after was the big guy himself, Aristotle. Galileo Galilei, using things like inclined planes and careful measurements, proved that Aristotle was wrong. He showed that all objects accelerate at the same rate. This was a huge shift. Observation and testing had now officially replaced pure philosophical reasoning in this race for the truth.
And then, Isaac Newton steps onto the track. He took the foundations laid by Galileo and all the others and built a complete system, a grand, beautiful clockwork universe, all governed by universal and, most importantly, predictable laws.
His first law gave us inertia, which is really just the simple but profound idea that things like to keep doing what they're already doing. It's kind of the universe's couch potato law. And this idea, building right on Galileo's work, was like the first big gear in Newton's new machine. His second law gave us this iconic formula, F equals ma. It's not just a bunch of letters, it's a precise mathematical tool. It lets you calculate the exact relationship between force, mass, and acceleration. Suddenly, the universe wasn't just philosophical, it was predictable. It spoke the language of math. And his third law, well, it just revealed this elegant symmetry in the universe. For every single action, there's an equal and opposite reaction. It's the reason you can walk. You push on the ground pushes you forward. It's how a rocket launches into space. It's everywhere.
So for 200 years, Newton's universe seemed totally complete. It felt like, okay, that's it. Physics is solved. We just need to fill in some details. But oh, they were so wrong. In the early 20th century, the next leg of the race would take a turn into the truly bizarre, and it would shatter that classical picture entirely.
And it all starts with this one, impossibly elegant equation from Albert Einstein. It revealed this startling, profound connection that no one had ever even dreamed of, that mass and energy are fundamentally the same thing. They're just two sides of the same cosmic coin.
He just completely upended our view of reality. With his theory of general relativity, he showed us that space and time aren't a fixed stage, they're a flexible fabric. And gravity isn't some mysterious force pulling things together, it's just the shape of that fabric, curved by the presence of mass and energy.
Now, if you thought that was strange, at the exact same time, a whole other revolution was tearing up the rulebook. Quantum mechanics revealed that at the tiny subatomic level, Newton's clockwork universe just breaks down. It's replaced by this bizarre world of probabilities and uncertainty, where particles can be in multiple places at once until you look at them. I mean, it's a reality that defies all common sense.
And that brings us to today. The baton has been passed to a new generation of scientists. But let me tell you, the race is far from over. In fact, in just the last few decades, we've discovered how much we still have no clue about.
Okay, get ready for maybe the most humbling fact in all of modern science. Everything we've talked about so far, from Aristotle's ideas to Newton's laws, from stars to galaxies to you and me, all of that only makes up about 5% of the known universe.
So what on earth is the other 95%? Well, we've given it some pretty cool names, but the truth is we don't really know what it is. About 27% is dark matter, some kind of invisible stuff that acts like the gravitational glue holding galaxies together. And the rest, a whopping 68%, is dark energy, an even more mysterious force that's causing the expansion of the universe to speed up.
So the ultimate goal now, the final leg of this race, is to find a single, elegant theory, a so-called theory of everything, something that can finally unite the two great pillars of modern physics, Einstein's world of the very large and the quantum world of the very small, into one beautiful picture.
You know, that relay race that started with ancient philosophers asking simple questions is still going on, right now, in labs and universities all over the world. The baton has been passed, and the most exciting discoveries, they might still be just around the corner. Thanks for watching.